Okay, so let's go over the answers to page 42 that you were assigned in the last video about skydiving. So a 90-kilogram skydiver jumps out of a helicopter at 6,000 feet above the ground. As he descends, the force of air resistance acting upon him continually changes. And the free body diagrams below represent the strength and direction of the two forces acting upon the skydiver at 6 positions during his fall. For each diagram, apply Newton's second law to determine his acceleration. So they're using 9.8 meters per second squared. We are fine using this as 10 because we've been using 10, so that's fine with me. So up here, right when he jumps out, he has it's 900 newtons down, so his acceleration is 900 newtons divided by 90 kilograms, so you would get 10, and you can use 10. Then here for the next one, the net force is 700, so 700 divided by 90 is going to be approximately the same number here, so we should have close to 7.8. Then in the next one, we're going to have at 450 feet, they're balanced, so his acceleration is 0. 3,000 feet, it's now 200 newtons upwards, so 200 divided by 90 is going to be about 2.2. The next one, it's 600 newtons upwards, so 600 divided by 90, and I get a little bit different number than this. It would be 6.7. If the next one I've got is balanced, so it is 0. And then up here, for the first two, the direction is down. For these two, the direction is up. So number one, at which two altitudes has the skydiver reached terminal velocity? Well, that would be these two where his accelerations are 0. So at 4,500 feet and 1,500 feet. At which altitude is the skydiver in the state of speeding up? So when his acceleration is downwards and he's falling down, that's when he's speeding up. So that would be 6,000 feet and 5,500 feet. 3, at which altitudes is the skydiver in the state of slowing down? This is when the acceleration is in the opposite direction of motion. So that would be 3,000 feet and 2,900 feet. Number 4, at 2,900 feet, the skydiver is blank. Is he moving upward, moving downward, and speeding up? So 2,900 feet, he is both moving downward and he's slowing down. So he is moving downward, he is slowing down. Number 5, explain why air resistance increases from 6,000 feet to 4,500 feet. So initially, air resistance increases up here because he is going faster and faster, because air resistance depends on the speed. And then why does air resistance decrease from 3,000 to 1,500 feet? That's because he has a larger cross-sectional area because the parachute has opened. All right, so let's look at page 43. So 43, we're considering, again, air resistance and terminal velocity. So number 1, when falling under the influence of air resistance and dropped from the same height, which will fall to the ground at a faster rate. A mouse, an elephant, or are they going to be the same? Well, the elephant will fall faster. 2, which of the following variables will have a direct effect on the amount of air resistance experienced by an object? That is, for which of these qualities will an increase lead to a resulting increase in the air resistance? So it is the speed and the cross-sectional area. We haven't talked about air density, but it really is air density, but you don't really need to worry about that. But technically that is correct because we haven't talked about density at all. Number 3, consider the dragster's motion below. Speedometer readings and the forward propulsion force F-ap are shown. The top or terminal speed is 120 miles per hour. Draw F-air force arrows on each diagram to illustrate how the amount of air resistance changes during the course of his motion. So as he is speeding up, his air resistance should be getting larger and larger and larger until he reaches his top speed, which is his terminal speed. And at that point, He's no longer accelerating, so his F applied equals his F air. Once this chute opens to slow him down, he has a significantly large air resistance, and he is now going to slow down dramatically. Number 4, draw F air force arrows to show how the force of air resistance changes on the falling skydiver. At A, the diver has just jumped, and at E, the diver has just reached terminal velocity. So initially, he's just jumped, so there is no air resistance, and then he's got a little bit, and it builds up, and it builds up until at E, he reaches terminal velocity, and they are balanced. Number 5, fill in the blanks in the following paragraph. As an object moves faster and faster, the amount of air resistance increases until a state of terminal velocity is reached. Once the terminal velocity is reached, the force of air resistance is equal to the force of gravity. Hence, the object will stop its acceleration. And at that point, that's the end of the paragraph. So, ladies, what I'm going to have you do now is work on 2 mop apps that cover these same concepts about air resistance, terminal velocity, understanding what the terms mean, and then you're ready for your curation project and finishing up the chapter. So email me screenshots if you're having any problems with the mop apps, and good luck.